is a video on solving simultaneous equations by elimination. We're going to go through 4 examples here and see if we can shed some light on it. So my first example is 5a plus 3b is 14 and 4a plus b is 7. We need to try and work out what a and b are equal to. First thing you always do is label them 1 and 2. Next thing you want to do is make either the a's the same or the b's the same. So how do we go about doing that? We could make the a's the same. You need to multiply this one by 4, this one by 5. That's quite cumbersome, but if we just times this bottom one here by 3, that'll turn this into a 3b, and we'll end up then with there. Alright, so that's what I've done there in the next line. I've taken equation 2 and I've times it by 3. I write it so I'm showing the examiner I know what I'm doing here, and that gives me, times by 3 gives me 12a, times by 3, 3b, times by 3 then gives me 21. And then I'm going to write out equation 1 then just below that. 5a plus 3b equals 14. The idea is to make one of the letters the same as each other. You can see we've accomplished that then with this step. In order to eliminate one of the letters, we need to subtract. So I'm going to do 2 take away 1. 12a take away 5a gives me 7a. 3b take away 3b means the b's disappear. 21 take away 14 gives us 7. Divide both sides by 7, I get a equals 1. So I have one letter worked out, I just need to work out the next one. The way we do that is substitute the a equals 1 back into one of these equations. We generally go for 1 or 2 here, and the easiest in my head is going to be 2. The numbers are a wee bit smaller and all that. So I'm going to substitute a equals 1 into 2. So there's equation 2, 4a plus b is 7. I'm now going to exchange my a for a 1. 4 times 1 plus b is 7. 4 times 1 is 4 plus b is 7. And then b equals 3. To make the examiner like me more, I then write along the bottom a equals 1 and b equals 3. So that's my solutions. Let's take a wee look then at the second example. So we have 4p minus 3q equals 1 and 5p minus 2q equals 10. I've already labelled them 1 and 2, so we're good to go. This one's a wee bit tougher for a couple of reasons. We can't just multiply one of them here. We're going to have to multiply both in order to make the p's the same or the q's the same. I'm going to pick the q's in this particular case. The other thing that makes this tougher is now there's minuses introduced, and that tends to cause a wee bit of mayhem, so you just need to tread very carefully. So here's what I'm going to do. I'm going to times this one by 2 to give me a 6q here, times this one by 3. So again, I show the examiner what I'm doing. 1 times by 2, 8p take away 6q equals 2. Then I'm timesing this one by 3. 15p take away 6q equals 30. What have I done? I've made the q's the same as each other. That was our plan. Looking at this now, we could do this one, take away this one, but it's going to give us negatives. We're allowed to do this one, take away this one if we want. So equation 2 take away equation 1, and that's what I've written there. 15p take away 8p gives me 7p. Minus 6q minus 6q gives me 0. 30 take away 2 gives me 28. Divide both sides by 7, and I get a value then of p equals 4. I've worked out my p, so I now substitute it into one of these numbers then to get my q. I think equation 1 looks easiest, so I'm going to go for substitute into 1. Write out equation 1. 4p take away 3q equals 1. 4 times by 4, because I'm substituting in my number 4 there, take away 3q equals 1. 16 take 3q equals 1. Some people can maybe guess the answer to this. We're going to solve it properly. The way I tend to do these is I don't like the negative letter, so I would take it over to the other side. I'm going to go 16 times, sorry, what am I going to do? 16 equals 1 plus 3q. Then I'm going to take away 1 from both sides. 15 is 3q, and that's going to give me q equals 5. I've switched those two round. I hope that makes sense to you there. And then the final line, p equals 4 and q equals 5 as our final answer then to those. Let's take a look at example 3. We have 2x plus y is 13 and 2x minus y is 3. I'm going to number them 1 and 2. And my first job is to make either the x's the same or the y's the same. Now this is a funny wee example because we've already done that. We actually don't need to do this first step that we've done before to make, see the way we multiplied here to make the b's the same as each other. We don't need to do this here. The y's are already both a value of 1, the x's are already both a value of 2. So we want to try and eliminate these then if we can. So what I'm actually going to do here is going to try and eliminate the y's, and you do that by adding these two equations. Let's see what happens if we add these two equations. Now we need to be careful here. 1 plus 2, so 2x plus 2x is going to give me 4x. Y plus minus y means it disappears, and adding these then gives us 16. So many people make a wee mistake there. That gives us then a value of x equals 4. There's a wee rule for this, and Mr. Reed's rule is the following. For the letter you're trying to eliminate, that's our y's, if the signs are the same as each other, we subtract. If the signs are the same as each other, for the ones you're trying to eliminate, we subtract. If the signs are different to each other, then you need to add the two equations if you want to eliminate. Okay, if you remember that rule, it'll save you an awful lot of hassle. We've got x equals 4. I'm going to substitute this into number 1. I know that for 13 is a bit bigger than the 3, but I like the idea of no negatives, so we're going to sub into equation number 1. 2x plus y equals 13 is equation number 1. 2 upon 4 plus y is 13. 8 plus y is 13, and that gives us y then equals 5. Final line, x equals 4, y equals 5. Nearly there. We're going to do one more. How exciting. It's the same question again. I like it so much I'm going to do it twice, but just to kind of make a point, I'm going to eliminate the other letter this time. First step is we number them 1 and 2. Next step is always you make the x's the same or you make the y's the same. In this particular case, the x's are already the same and the y's are already the same, so we're already good to go. I want to eliminate the x's, and Mr. Reed's rule says for the ones you're trying to eliminate, if the signs are the same, we subtract. If the signs are different, we add. For the ones we're trying to eliminate, which is the x's here, the signs are the same, they're both positives, so we're going to subtract. I'm going to do 1 take away 2. You can't do 2 take away 1, you just end up with a few minuses, but that's okay. And again, we need to tread really carefully here. This is where most people will make their mistakes. 2x take away 2x gives you nothing, it disappears. Y take away minus y, that's y minus minus y. That's the same as y plus y because of the two minuses. So we get 2y, and we're subtracting here, and we get 10. That gives us y equals 5. We're nearly there. We just need to substitute back in. So we're going to substitute into number 1 again. Substitute it back in. 2x plus y equals 13. 2x plus y is 5 equals 13. 2x equals 8. And then x equals 4. Final line to let the examiner like you more. X is 4 and y equals 5. And that's us finished.